Hey mathematicians, let's do your homework. Okay, so we're starting with some multiplication of decimals. Remember that I told you we are going to straight up ignore these decimals. We're going to call that 24. And you have two choices. We can call this 15 because we don't need our trailing zeros, or we can call this 150. I personally would rather call it 15, but I'm just going to make sure that I cross out that 0. If I decide to multiply this as 15, then I cannot come back and count that 0 when I'm counting decimal spaces. So I'm going to do 24 times 15. Two choices. I told you can traditionally stack them like this and multiply. If you know how to do that, great. That might be the more efficient way. If you want to do that and you don't want to do the next strategy, that's fine. If this is hard and or you are consistently getting these types of problems wrong, then another option is an area model. I see that this 24 has two digits, the 20, that 2 in the tens place, and the 4. And the 15 also has two digits. This is what's going to cause me to do a 2 by 2 area model. So I'm going to say, okay, that 2 is really 20. And 4 together makes 24. If you want to put a plus sign here, you can. It's not required. 1 plus 5 does not make 15. It's a common mistake to write 1 and a 5, but really this is 10 and 5, because that 1 is in the tens place. Then I'm going to multiply. 10 times 20, well, 1 times 2 is 2 with 2 extra zeros. 10 times 4, 1 times 4 is 4 with an extra 0. 20 times 5, 2 times 5 is 10 with that extra 0 from the 20. And 5 times 4 is 20. So when you solve it like this, you now have to add up all of your partial products, your partial answers, to get one final answer. Similar to over here, 5 times 4 is 20. Oh, look, it's that 20. 5 times 2 is really that 5 times 20, that's 10, but really it's in the tens place, so it's 100. And then this is where it deviates. It's a 120, 12 goes there. You put a placeholder 0, 1 times 4, but really you're putting that 4 in that 40s place, so you can kind of see how they're similar. And then 1 times 2 is 2, that's in the hundreds place, that's like your 200. So then just like you have to add in both options, just like we added over here. I'm going to keep it going with the area model. All of those are zeros. 0, 0, 4, and 2 makes 6. 2 and 1 makes 3. So we've got 360, much like if we did it over here, we'd also get 360. But that's not our answer. We have to put decimals back in it. So I'm going to count from the end. I have 1 decimal place here, and I chose to write this as 15, not 150, so I'm ignoring that last 0. 1 decimal place here, that means I'm going to move it in 2 times from the end, and my true answer is 3 and 60 hundredths, or I could write it as 3 and 6 tenths. That's the answer for the first one. For number 2, a grocery store sells jelly beans in bulk for $2.75 a pound. If Wanda buys 1 8/10 of a pound, we're going to pretend this says 275 times 18. If you know how to stack it, you can stack them. If you're going to do an area model, you're going to have a 3-digit by 2-digit or a 3 by 2. It does not matter if your 3 is your columns or your rows. You just need 6 total little boxes. And this would be 275 times 10 plus 8 is what makes 18. Multiply them all out. Get all your partial products, add them all together, and then move your answer in 1, 2, 3 decimal spaces from the end. Number 3 is a multiple choice question. You cannot just pick a random one. I need evidence that you thought it through. A team of workers took 16 and 73 hundredths of an hour to complete a task. A smaller team of workers will complete the same task, but it will take them 1.5 times as long as it took the first team. Time. Based on this information, what statement is true? The task will take the smaller team of workers 8.23 hours to complete because, oh wait, here they added. This says times. So this one's not true. Even if mathematically it's true, which I didn't even check, it's not what we're doing because we're not adding, we're doing multiplication. Same deal with B, we are multiplying. So down here we see the same multiplication sentence and just two different answers. There's no way to know which one is our answer without checking. So we're going to do 1,673 times 15. Notice that I completely dropped my decimal points. Did not even write them in. I know that 5 times 3 is 15. I know that 5 times 7 is 35, plus 1 is 36. I know that 5 times 6 is 30, plus 3, 33. I know that 5 times 1 is 5, plus 3, 6, 7, 8. I know that I need to put a placeholder 0 here. Wait, actually, I know what the answer is right now. See if you can figure it out. If you can't, that's fine, keep going. But I know that I'm going to end up adding these, and that this is going to end up being 5 plus 0, which is 5. There's only one answer that ends with a 5. So that is not cheating, that's not doing less work, that's working smarter, not harder, and recognizing, wait, I don't need to do that entire problem. I know that only one of the answers ends with a 5. Mathematically, I can prove that this must in fact be my answer. On the back, we're not multiplying with decimals, we are reviewing absolute value and ordering integers. So in the back, we are looking for the lowest score. We're looking for, key vocab word here. You're not going to know what to do if you don't know what this word means. This has been a vocab word we've been quizzed on. It's a vocab word you need to know because it has appeared since probably 3rd grade, and it will continue to appear all the way through 12th grade. Sum means you need to add up all these numbers. Here we have a few numbers. You need to tell me which one is closest to 1 on a number line. Here, same idea. We have a number line in case you wanted to plot these 4 numbers. Which one is closest to 49? And with the numbers right here, we're going to list them. We're going to list them in order from least to greatest. So the smallest one first, or the most negative one. I already know that the greatest one is going to be that 6. And then you need to decide which one is bigger, 5 2/10 or 5 800 to decide where you're placing those two. And that's it. I'll see you tomorrow.